right, so let's start off. See, organic lab, my estimation is like this. Your theory is not going to be that much in terms of understanding, in terms of what I've understood. Your teacher at school is very competent. He's very good. So your theory, I don't think there's going to be that much of an issue. Organic lab, more or less, you're going to be having issues only with problems, interesting problems. So as and when we are having sessions, do not worry about what to say, whether topic is completed. वो सब सोचो मत. If you have any problem doubts, we will discuss them directly, and we will proceed on in that direction from now on when organic is happening. Because organic mein your practice is paramount. I think last session itself I mentioned, if you want to the best identifying mark to know if you have made it with respect to organic chemistry is when you start having fun solving questions.
Yeah. Yes.
So that has to be your end game ideally. So practice and more practice. And let me start off with this now itself, so that you can keep an eye on it when things are happening. When you are learning organic chemistry, you have to treat it like inorganic chemistry in the beginning, but then apply your brain like physical chemistry. In a sense, in the beginning, you do not have any data in your brain about organic chemistry. So you will have to treat it like inorganic chemistry in the sense you'll have to memorize the data.
Memorize everything. Yeah.
Properly in the first place. Once you start making connections, then you can forget. Inorganically, you'll have to remember the marker points anyway, but organically, even that you can more or less to some extent forget because it will connect to everything else. But initially, you will have to sit and memorize properly. It will help a lot. So from that point of view, what you should be doing is this. Abhi ke liye, there is no issues at all because this is general organic chemistry. But when the chapters start happening, every chapter in organic is going to be a cumulative chapter only. There is no standalone chapter. That is the biggest problem which children face when it comes to organic chemistry. So if you're looking at the kind of problems which normally students end up facing, the real issue happens when, first 2-3 chapters, they'll be comfortable. But when it comes to the 4th or 5th chapter, when it comes to alcohols, phenols, ethers, aldehydes, ketones, what happens is you will need to know about alkenes. Without knowing alkenes, you can't touch aldehydes, ketones, because in the question, they are never going to be asking you only on aldehydes. There is no question which is going to be made like that. They are not idiots. So you will have to start realizing the way to play the game in organic towards the end will become like physics, where you have to start connecting Newton's laws of motion, friction, and center of mass and everything, and then get to rotational dynamics. That is how organic in later parts is going to be. But organic in the initial parts will feel like inorganic chemistry.
Yeah.
So when you are learning chapters like hydrocarbons, make sure you are making a good synopsis.
Yeah.
As and when, even now for GOC also make a good synopsis.
Yes. Yeah.
What is the synopsis? It's literally a bit sheet. Yeah. If you're allowed to write the exam in an open book manner for this particular, for whichever exam, what would you like to take? And you're not allowed to take too much stuff. You're only allowed to take bare minimum, which you can take, you're allowed to carry. Think of it like you're allowed to carry what you can smuggle inside your underwear. Nothing else. So it's just they're not going to catch you.
Yeah.
You can imagine it like that. So literally, jo tu bit mein likh sakta hai, that is going to be what you have to basically minimize the thing. Refine it as much as possible as to what is required for you to remember, and then go with it. Okay, now let's start off. So what has happened in organic for you in this current set of days?
So we finished geometrical isomers and we today started optical isomerism.
Okay, so you have done configurations to some extent then.
Yeah.
So all right, so give me a quick blow by blow as to what all you have learned in this time. Geometrical, what were the key examples you guys saw?
Sir, we saw in first of all cycloalkenes,
Hmm.
and then
Cycloalkene.
yeah, kene.
Cycloalkene, there is no geometrical isomerism. Cycloalkane, there is alkenes you have seen. And I am assuming, what is that other, what to say, E and
Ketoxins. ENZ also we did, yeah.
okay. And cycloalkane basically includes all cyclic.
Oh, okay. Sir, why doesn't cycloalkene show? Right.
We will get to that when we get to it. We will talk about cycloalkene. Since you have mentioned that, I'll discuss that also. I'll talk about why that doesn't show.
Oh.
I think sometimes I end up giving unnecessary extra information, which makes you have more questions. So, yeah, next. ENZ okay?
ENZ, yes, done. And then
Then you have done Khan and
small
Gold.
Khan. Oh yes, yeah, we done that. Yeah.
Okay. This is very
And
important. Khan
then
and Gold. And what else?
calculation. Wait, sir, what do you mean by Khan? Like,
The rules
oh, the
for
rules. Yeah, yeah, yeah.
priority.
Priority, yes, we've done that. Yeah.
Uh,
And then
okay.
calculation of number of geometrical isomers.
Number of geometrical isomers.
Yeah.
Okay. And
And optical
mm,
isomers.
you did syn and antioxide
Yes, we've done that. Yeah. And spiranes also we did.
and
Spiranes.
spiranes. What are these?
Like multiple, like it's like this
Draw it
algorithms.
and just show me a photo or just show the camera on that.
Like like this.
Oh yeah, so those are called spiranes. Effectively, MS Chauhan. Okay, ठीक है, fair enough. Okay, I just put that's.
And then fused bicyclic compounds.
If you have done this crap, then have you done diene cumulative?
Yes, yeah, we've done that. Alliums. Yeah.
Yes, allenes. Yeah.
And
Okay.
then this fused bicyclic compounds.
Yeah,
Like
basically, I understand. Once you showed me this thing, I know what you're talking about there. So basically, the entire concept
okay,
related.
okay. Yeah, that's it.
Effectively, you will also have these weird fellows. What are they?
Yeah, yes. Oh,
This kind of crap, no?
yeah, but then like we didn't do many examples with
Yeah,
yeah,
they're all
some
effectively your teacher was covering his ass. That's all. Nothing else. Your teacher never meant to give you a proper, what to say, full-fledged crash course of that. He just wanted to make sure, what to say, exam if it shows up, he's made it clear that, yeah, this can show up. You've been touched upon that. Good. He's a very good teacher. I really appreciate that. See, this is the mark of a good teacher. Someone who knows, but the problem is this. It doesn't matter how good you are. The system is corrupt.
yeah.
And that is the problem which happens once you go high enough up. You start realizing, yeah, system's not system's got issues. Do you really need these spiranes, these allenes and shit really? Allenes maybe yes. These spiranes really?
No,
No. But why is it that someone who is, I can sense your
could
teacher
show
in
up.
your school is very good. In the sense he's very sincere to his craft of teaching you. You guys
Yeah,
basically. And someone like that is obviously clear about the fact that this is never going to show up.
yeah,
But that person is teaching you this.
yeah,
And you remember what I told you about inorganic in the beginning. The more junk you keep in your brain,
yeah.
the
Yes.
more difficult it becomes to make the meaningful connections. It becomes irritating when you start seeing the system like that. And how old is your teacher?
He's like 40s, somewhere in the 40s.
End of 40s.
No, middle mid-40s.
Middle.
Yeah.
All right. Let's get to it. So this bunch you have covered. What else have you covered then?
So optical.
Optical. Before optical, you'd have done some touch up, na? What all?
Uh,
Formations and
like,
configurations. Which configurations did you do?
sir, we didn't do any configuration.
Okay, maybe the nomenclature which I'm using is different here. Did you do sawhorse projection?
No.
Okay. What did you learn in optical isomerism? What did you start off with? How did you start off?
Well, we just like wrote down like the definitions and all. That's about it. Yeah.
Give
Nothing
me the
much in.
definitions which you learned. Quick blow by blow.
Uh, Compounds with the same molecular formula. Wait 1 second. Yeah, compounds with the same molecular formula and structural formula, but difference in the direction of rotation or degree of rotation of plane polarized light are called optical isomers. Yeah.
Okay, your teacher is going the clean way. Let him finish. I don't want to poke here. Then. So he is taking the correct approach here, and yeah, let's not touch that now.
Okay.
I'll let you finish it, then I'll do my poking. It's not good
Okay.
to poke before things are clean. Or if you have some doubts about that, which you have already discussed, which is already talked about, and you didn't understand clearly, then you can ask, did you learn plane polarization? What is meant by plane polarized light? What is meant by...
Yeah, like initially it's like the light molecule is like vibrating in all directions, I guess. And then when it goes through the prism, then it becomes only in a single plane.
Okay.
Is that
What? Okay, go on. Continue.
and then that these plane like the plane polarized light get projected through a like a solution of a compound, and then based on whether the compound is inactive, optically inactive, or like the other stuff, it rotates and all like that.
Okay, so sir has already, your teacher has already discussed the basics of what is meant by that.
Yeah,
That
that's it.
is done.
Nothing more than that.
That discussion is done.
Kind of, yeah.
Okay. What did you understand by optical activity then from that?
Like uh like if the compound, I'm not sure, but I'm guessing if the compound is, I guess, maybe non-coplanar, then maybe it.
Okay, so let's break it down slightly here as to what's happening. So effectively, what's happening is something like this. There are a couple of parts where I saw that your understanding had some gaps. Let me just hash out on that. First was, what is unpolarized light? So what is meant by unpolarized light here? So when you take a light wave is what is called as an electromagnetic wave. All right. So what does an electromagnetic wave mean? It means if I'm going to be considering it as a wave, the wave is going to be something where it is oscillating in 3 dimensions, where one
Yes,
dimension is going to be having the electric field oscillating, one dimension
magnetic
is
field.
having magnetic field oscillating, and in the other direction, you'll end up having the direction in which it is moving
Velocity.
oscillating.
Yeah.
So you're going to be having 3 parts to the light wave. One is going to be your electric field. Let's say this is or let's take this guy's electric field here. My index finger is electric field. Let's say my middle finger is going to be representing my magnetic field. Actually, no, index finger I'm taking as direction of propagation towards you. Basically, I'm having a light beam. I'm shooting it towards you. So
Yeah.
direction of propagation, electric field is my thumb. Magnetic field is my middle finger here. So this is going to be a light wave, which is going to be technically only one piece. If I'm somehow isolating one wavelength of light or whatever that, I mean, one individual photon, it will technically be like this. But in general, you are never going to be having one photon. So what happens is you're going to be having a beam of light. So when you have a beam of light, what that means is you're going to be having these waves are technically going to be, 1 second. Yeah. So effectively, you're going to be having this as a light wave. So what happens over here is you're going to be having the light wave as it is moving towards you is going to be something where each of these three have to be mutually perpendicular to each other continuously. But I'm going to be having it technically present in all directions like this. As long as the direction of propagation is going to be the same. If I'm shooting a beam of light here from a torchlight to you, the direction of all the beams is this way. So direction has to be this, but the electric and magnetic field are possible in every direction. So what happens is, if I'm going to be taking, say, something which is going to be called, what to say, a Polaroid. I don't know spelling and all for that. I'm assuming this is or polarizing. Nicol prism is a typical goddamn example. So let me go with
Nicol prism.
So if I'm going to be taking a Nicol prism or your modern sunglasses, most of the sunglasses that we have are all polarized glasses now. What happens in that particular case is you're going to be having this particular type of light where you're having all of this in every direction. Electric field and magnetic field are in every direction possible, while direction of propagation is one, is going to be called as unpolarized light. What this Nicol prism is going to be having is, it is going to be something where there is such a unique structure for that system where it is capable of physically creating a shadow on a particular direction, and it literally physically cuts off a chunk of the light by absorbing it. That is literally what happens. How is basically, think of it like this. If I'm going to be having, say, there's a light over here, obviously, right? You can see that in this case here, this part of my face is looking dark. Why?
Dark, yes.
Why?
Because light doesn't directly fall on it.
Exactly. Why? Because it's in the shadow. Correct? It's in the shadow of this side's light. You can see this part very clearly because there's a light over here, obviously. So when we are talking about a shadow, literally the shadow is a part where the light is cut off, correct? The Nicol prism is something where at the crystal level, at the molecular level, it is able to apply a shadow. That is the best analogy which I have about that. I don't exactly know how it is cutting off. My understanding is at that stage, it will go into quantum mechanics. And it's going to be relatively unsolvable beyond a point. It is going to be very complicated. I will probably not be able to understand the math. But in a sense, the best way to imagine it is, you can think of it as, it is literally creating a shadow. It is literally absorbing a part of the light. So why is it that this shadow is created over here? Because my skin has absorbed the light waves, correct? Chunk of it is reflected and it is what you're seeing, but a bunch is definitely being absorbed. Correct? So that is basically what happens over there. So when you're going to be having a Nicol prism, the internal structure of that thing is going to be something where it will actually be able to create a shadow at things. Now, forget about how it does that now. That doesn't matter, honestly. Let's talk about what it is doing now. So what it does is, I'm going to be, this part you got it correct. So let's directly talk about what's going to be happening here. Usually what we'll be having is, we'll be having a tube. On one end, we will be having this, what to say, Nicol prisms, polarized. Give me a second, dude. My friend is calling me. Let me just mute you for a minute. Yeah, sorry, dude.
Yes.
Yeah, so where was I? Yeah. So let's say I'm going to be having a Nicol prism, a polarimeter, a Polaroid taken here. So what's going to be happening is, let's say this is going to be what is called as a vertical polarizer. Now, honestly speaking, I do not know what the hell a vertical polarizer is supposed to be exactly defined as. It could be that it cuts off the vertical, or it only allows
keeps the vertical.
I don't really care what the definition is. I'm going to choose one and go with it. It's a 50-50 choice. I am not interested in debating that choice. All right. So now,
Yeah.
so there is going to be a polarizer available, which is basically a lens. What's going to be happening? I'm going to be shooting some light through it. When I shoot some unpolarized light through it, the original electric field, let's say was my thumb, it was going to be in all directions. Now, when it is passing through, this guy is going to be allowing only the vertical component of electric field to pass through. Meaning, anything which is going to be tilted like this at an axis, let's say. What happens is this particular electric field is in this direction here, correct? So this guy's vertical component part alone will be allowed to pass through. The horizontal component part of it will get absorbed away.
For the other one also, right? The other finger.
Any piece which is passing, let's say something like passing like this.
Then the component of the middle and the thumb.
Component in this direction, the horizontal will get taken away, will be absorbed away. The component in the vertical will be allowed to pass through.
Both of them add up. Okay.
No, don't think about what is happening beyond that.
Okay.
See, the mistake you are making is, I told you about your mistakes there, assumptions. I didn't tell you what happens to the remaining there. Don't make that assumption there. Your vector summation from physics tells you, oh, add ho jayega. Nahi. Don't assume. We do not know. Yes, my physics also tells me there is a good chance it will add up, but I do not want to make my mind up over that because I do not know for sure. And I've not done the math over there to understand that shit anyway. This is all conjecture from my part. This is all my understanding of it. So no book will give you this kind of crap anyway. So the fact is, bulk of the things you would have probably realized by now, most of the shit which I talk about, we don't find in books.
Yeah.
So the idea there is books are basically, how to put it, when you have enough to teach or when you have too much content, you will not write a book. You cannot. There's too much in your brain. You will generally be writing the book only when you are much older. So youngsters who are writing books generally, are frictious people who cannot stay properly in one place. And book writing is a way out. Anyway, coming back to the aspect here. When you're going to be having, this Nicol prism here. So this guy here, if it's a vertical polarizer here, let's say it allows only the vertical component to pass through. So if it allows only the vertical component to pass through, I will initially be sending in unpolarized light, which technically will be capable of oscillating in any directions. I will be having what is called as plane polarized light, PPL. That is going to be the abbreviation which is going to be most commonly seen in this part here. It is called as plane polarized light, meaning the electric field and the magnetic field component are polarized onto one plane. Electric field in this case will be on the vertical, magnetic will be on the horizontal. That's the idea here. Now, what is the optically active substance bit here? Let's start off with something from physics first. I'm going to be having two people, person 1, person 2. I'm going to be having both of them technically having a velocity in this direction. Okay. One small problem though, I'm going to tie a chain between them. What will happen now? If this is V1, V2, let's look at the cases. If V1 is going to be equal to V2, what will be happening in the case?
They'll move parallelly.
They'll move parallelly, they'll move straight. If I'm going to be having V1 greater than V2, what will happen in that?
You'll pull that towards this thing. Like it'll end up becoming like V1.
What will be that path?
Like P1 will go straight, but then this P2 will also.
Will they be straight? Think. Don't do math here. Don't do math here. That's the reason I'm giving you an analogy. Think if I'm tying you up to your mother and I'm making you both run. What will happen? So effectively, you will run a little bit more distance in the beginning first.
Yes.
But you'll get pulled. When you get pulled, you'll turn.
Yes, circular. Not circular, but
both will effectively form a chord type thing. Both of you will go into motion which is going to be circular type. Because you're getting pulled is going to make her get pulled also.
Yes, yeah.
So effectively, the motion which is going to be followed will be something like this.
Yes, yeah. That's it.
Right? Not exactly circular, but a huge circle's part. Right?
Yeah.
So effectively, you are going to be having a tilt happening here. Why did you have the tilt happening here?
Because something is pulling both of them, right?
Because these two parts were connected to each other. They were part of the same whole. And this part and this part are traveling at different velocities.
Yes. Yeah.
Correct? So you had a bending happening. So you had an angle being created because of that. Correct? So what was my original path? It cleaved into a different angle there. It made an angle with that original path. Yes or no? This part is properly clear?
Yes.
So if I have a piece which is a part of a whole and different parts of that piece are traveling at different velocities, we will have a bending scene.
Okay. Yeah.
Can I put it like that?
Yes.
Does that make sense to you? You agree with that?
Yes. Yeah.
Now, let's go for what's going to be happening. So in this case here, we are going to be having plane polarized light. Okay. Now, if I'm going to be having one more Nicol prism here. Okay. If I'm going to be having this guy being a horizontal polarizer. First was a vertical on one end of the tube. On the other end of the tube, I'm going to be having a horizontal. What will happen?
So assuming it lets out horizontal or like it removes horizontal?
How does it make a difference? Same definition of vertical Joule, yeah, uska opposite.
Okay.
The vertical, if you look at us, the vertical is kept there, correct?
Yeah.
So we will take this also, it is kept. Yeah, problem.
Yes, that's what. Only the vertical will pass through because there is no horizontal.
Good. So in this particular case here, in the vertical polarizer there, the vertical pass through. Okay. And in the horizontal should pass through.
Yes.
Correct. So after it passed through the vertical, was there any horizontal left over?
No.
No. That means when it passes through the horizontal now.
No. It's like a point.
No, there is nothing. You see black. You don't see the light. It becomes opaque. Correct. You remember what I told you? What does forming a shadow mean? My face is creating a shadow, was creating a shadow here. Why? Because my face is opaque. Correct. Opaque is absorbing.
Correct. Yeah.
So in this particular case here, this guy should be opaque. Correct. If it is a perfect horizontal fellow, it should be opaque. That is the case when you are having an optically inactive substance here. If I fill the tube up with an optically inactive substance, implies this is opaque or empty. So if the tube is either filled with an optically inactive substance or if the tube is empty, I will have the other end being perfectly opaque. Now no light will pass through because there is no there is no horizontal component left over for it to pass through.
Yeah. Yes.
Now, here's the interesting thing. If I have inside this something which is an optically active compound,
It would rotate.
So what is that guy going to be doing? So originally, my plane of polarization was this. My electric field was only in this direction, in this vertical plane there. So when I'm letting it pass through, it will basically get rotated like this. Slight rotation to an angle. This much angle it will rotate it. Because it is now rotated and become at this angle, now there is a horizontal component available. Right. So now when there is a horizontal component available, what can I do now? I will now see some light.
Now, yes, on the back end.
That is why it is called as an optically active substance.
So, but then what does it do to rotate the thing?
Now, we are not done with game here yet, or we're not done with the stuff here yet. So let's continue on. So effectively, it has rotated. Now, let's talk about what is this optically active compound really. This is a compound which has no symmetry, no meaningful symmetry.
Okay.
Now, what does this no meaningful symmetry lead to over here? So when the compound is having no meaningful symmetry, you can think of the compound like this, where there are 4 parts of the compound where all 4 parts are technically different. So effectively, whichever way in which I divide the compound into 2 parts, both parts are never going to be having the same density. Molecular level pe, atomic level pe. Because there are different substances present, there is no symmetry there at all. Now, let's talk about light a little bit. What have you learned about light when it passes through different mediums?
It bends.
No. Is that what you learned?
It refracts.
What? Why does it bend? You learned why it bends now.
Because its speed decreases.
Its speed changes. That's the key point I'm looking for there. So when light travels through a medium, the speed at which it travels ends up changing depending on the type of medium it is traveling through. Correct? So in this particular case here, this is an optically active compound present here. Usually, this optically active compound here will be in the form of a solution. So if it's in the form of a solution, obviously light can pass through it. So when the light is passing through it, now this is where that example we talked about comes in. What is going to be happening? A light wave is like a huge wave passing through. When that wave is passing through different parts of the same molecule, different parts of the wave will move at different speeds now.
Yeah.
Which is in some way related to what's going to be happening there in terms of the bending of the light over there. When they say that the plane of polarization is bending, the light is remaining the same. Nothing changes in terms of intensity. None of that is going to be changing beyond a point. But the plane of polarization gets tilted, which is where that example which I gave you earlier comes into play. So you can think of it as a whole piece is moving, where you're going to be having different parts of that whole piece are moving at different speeds, which creates a bending effect as it is moving through. That bending effect is what is going to be seen as an angle. You measure it as an angle. That is basically what you're going to be having as optical activity. That plane of polarization, which was originally vertical, tilted by a particular angle. That effectively is what's going to be happening in this case
here. Okay.
This is the, what to say, this is the way in which I have basically understood the concept there. But the truth is, my explanation is probably too simplistic. The truth will probably be a lot more complicated. But what I discussed more or less fits all the pieces. So you'll end up having the understanding behind how optical activity is happening is basically this. What is happening? Why is the plane of polarization tilting? This is more or less the rough reason as to why the plane of polarization is tilting. Now, what is the reason why it tilts though? The reason why it tilts is because the molecule it passed through had no symmetry. Correct? Because that molecule had no symmetry, the wave which passed through had different velocities when it was passing through different parts of the molecule at the same time. At the same time. That is the key thing here. Because light ke beech mein you can't talk about, it's the same wave. It's like the same wave passing through the same molecule at the same time.
Yes. Yeah.
But it is getting but there is different velocities though. How will that be reconciled? We can't think about how it's going to be reconciled, because the moment you go deep into that, it just goes completely out of whack.
Yeah.
The idea behind light waves traveling at different speeds in different mediums actually treats the wave as a particle. All right. That is the reason why you end up having it. Effectively, you can say that compared to a vacuum, That's what your dielectric constant and all of that comes into play there. Compare, or what is it? Refraction, what is that constant, man? Mu,
Refractive index.
Refractive index, correct. Yeah. So compared with the vacuum, how much resistance to light is this guy giving? How much resistance to the movement of light is this guy giving? That is what refractive index effectively is.
Yeah.
How much slowdown is it going to be creating, basically? So when you're going to be having light being completely treated as a wave, it goes a little bit differently. So the understanding is what I told you, but the way it is treated mathematically will be different. Now, coming to what is going to be happening here. So the extent of tilting, what will that depend on? So we talked about how the tilt is happening. Correct? The plane originally was this was plane polarized light. It got tilted in this angle by some angle theta.
Yeah.
Right?
Yeah.
At start, at final. So what is this tilt depending on? What do you think it depends on?
How asymmetric the compound is.
Obviously.
Yeah.
Other than that, how many molecules it passes through, right?
Yes.
Bluntly, that is the key thing, right? How asymmetric it is going to be the individual compound's property, which we
concentration.
Can do. So this theta here is actually proportional to what? It is proportional to number of optically active molecules light wave passes through. Right? So that is going to be something which later on you'll be learning. I mean, I'm sure you'll be doing it in a class soon. This is going to be something which will effectively be proportional to the length of the tube. And it is also proportional to the concentration of the
solution.
Concentration of solution. This is generally taken in grams per ml.
Okay.
Remember, these are all archaic things which were done a long time back. So at that time, the standardization they used was grams per ml, and this was taken in decimeters. Yeah. A little bit irritating, but not that bad.
Yeah.
Now, anyway, coming back to the point over here, you're going to be having this a little bit more in detail being discussed upon in your school anyway. So I'm not going to touch upon that. But this is basically what's going to be happening in terms of optical activity. So the optically active compound, what is special? It has no proper symmetry element, which is meaningful. That is the key thing. So, okay, now let's go back to something other than optical activity, because I think I've covered off most of whatever you have done in optical activity by now, correct?
Yeah, that's about it. Yeah.
So whatever doubts you had till now, I think they should be okay by now. Now you can proceed on for learning in your class properly. Let's go back to the older topics now.
Sir, I have one doubt in EZ system of nomenclature. Sir, an example.
Yeah.
So there's a C triple bond.
Alkenas? Let's take an alkene.
No, no, this is EZ nomenclature to see which one gets more priority. Like
the side which gets more priority, then?
Yeah, the side, yes. The can.
So one side, let's see triple bond C.
One side C triple bond C, and then attached to that, there's another CH3.
CH3, yeah.
Yes. Okay. This one or CCC. CCCH3. Okay, wait. So, 1,2.
One second. No need to give numbering. Tell me what group on that side there. Name that group and tell me the
CH3.
Name that group as a substituent and give me the name.
Methyl group. The full thing. Oh, sorry. No. So 1,1,2,2 tetramethyl propyl.
So it's 1,1,2,2 tetramethyl propyl. Okay, all right. So
that's it. Yeah.
This guy?
Yes. And then we need to compare which one gets more numbering.
Which one gets higher priority in terms
Hi.
of the numbering.
Yeah.
Okay.
So, uh, you can write this C triple bond thing as two other single bonds, right? With carbon.
You're right.
Yes.
Go ahead and go with it in that sense. In the sense, obviously, it's meant for that kind of tricky nonsense only. So let's say you're going to be having this carbon here. It is going to be something where atomic number is same as this side. Atomic. I'm assuming you've got the rules done properly so far.
Yes. Yes.
So we go with what first? We go comparing atomic number first.
Number. Yes.
Then we compare atomic mass of that location. If they
Yes.
are isotopes, heavier isotope
Yeah.
gets higher priority.
Higher priority. Yeah.
That
Yes.
part has been discussed, I suppose. Yes.
Yes. Sir. Yeah.
Because that is going to be key here to break the deadlock.
Okay.
Okay. Now, so in this particular case here, this guy, how many atoms are attached to this carbon here? 3 carbons.
So 3 carbon.
So
3.
it's going to
Sorry.
be 3 into 6. So it's 18.
Oh yeah. Yes.
Atomic number, samdane. You know the rules properly or not?
Yeah. No, I know, sir. I know.
So this carbon here will have 3 carbons technically connected to it. So its atomic number sum of the atoms connected to it is going to be 18. Yes or no?
Yes.
That part is clear clearly.
Yes. Sir.
This guy is going to be connected to 3 carbons as well.
That also 18.
Okay. Now, next, you're going to be having this carbon has to be taken next. Correct?
Yes.
There are 3 such locations for this guy to pick now.
Yeah.
And this fellow is the one we are going to be picking over here, which is going to be similar to this fellow.
Again 18.
This guy is attached to how many more here? 18 again.
Yeah.
This guy is also 18 again.
Yes.
And on this side, this is going to be 3. This guy is going to be 3. Fair?
Yeah.
This is what your conundrum was.
Yes, sir.
So effectively, this chain and this chain seem to have similar levels.
Yes.
But there is one small part you are missing out on. This guy has extra connections.
Yes.
These extra connections absolutely end up bringing this guy to be having higher priority. Why? Basically, you should be comparing them with nothing. That carbon should have had hydrogens, but it has got nothing there.
Yes.
So, technically speaking, you need to compare them with that type of situation only. So, in this particular case here, if I have to give priority, put a gun to my temple and basically ask me to give priority, I'll give this higher priority. I will give this lower priority. If I am not having a goddamn gun to my temple, I will not sit and waste my time on unnecessary bullshit like this.
Okay. Yeah.
Am I clear with what I'm trying to explain here?
Yes, sir. Yeah.
So this is going to be something again where your teacher has noticed this as something which is being asked in internal exams to just screw with kids.
Yeah.
And he wants to make sure, since he has noticed this, he wants to make sure his children are benefiting from it. So now in this particular case here, what do I mean by benefit here? There is only benefit in the short term to be looked at. So his children are not benefiting. So he wants to make sure he is benefiting from it.
Yeah.
Because if this bullshit question is asked, honestly speaking, I would recommend you just not give a shit about it and move the fuck on. Sincerely. It's not worth wasting time remembering that, oh, if this comes like this, I should make sure that, oh, this guy was given higher priority by the examination. Why? Why? Nobody cares. Nobody cares about this. This is just going to be that flexing point within like a very, very tiny niche crowd inside your class. Which is cool. Which is the crowd you are part of, or which you hope to be part of, or which you're already part of maybe. But it doesn't serve the purpose in the larger game. So what I would recommend is, if the answer goes with the logic which is similar to your isotopes, remember it as same as isotopes, forget about it.
Okay.
which is what this is.
Okay.
And since I do not remember it at all, that means it is same as isotopes. Forget about it, logic. Mostly.
Yeah. Yes.
You understand what I'm trying to tell you here?
Yes, sir.
You have to come up with a more cleaner logic by which you don't need to remember all of these kind of unnecessary junk information.
Okay.
But at the same time, you have to prioritize that logic more. In the sense,
Okay.
if this was different priority, let's say in your school, they have told you that the alkyne fellow is a higher priority. If they're given that is a higher priority, what would be the answer over here from my side? I would not have really questioned it. It doesn't matter to me what is the priority there. Is it my money there? No, I don't really give a fuck what priority order is seriously. It doesn't make a difference. It's just against my logic. So what will I remember? Oh, this is weird. I won't even remember this is supposed to have this answer. I will remember this is weird. That's all.
Yeah.
You understand what I'm trying to tell you?
Yes,
if it is weird, what is the only way in which it can be weird? It has to be 50-50 only. At the end of the day, if your logic is cold enough, it will come to 50-50 choice. So when it comes to that choice, oh, this is something I remember as weird. That means what I think here is not what it is supposed to be.
Yeah. Yes.
You understand the way to go about it? So
Yes.
that is the kind of marker you should be remembering. But honestly, don't waste a marker on this sincerely. My gut feeling tells me it is not something where you should waste a marker, which means it is going with a common sense logic. What was given as higher priority by your teacher?
Yeah, this one only.
That means no need to bother. No need to bother.
Yeah.
That means it's not something which is outside. It is the same piece only. Same logic works. Don't think too hard. You understand the principle here then?
Yes, sir. Yeah.
Okay. All right. Next.
Uh,
There should be more doubts then. If you've gone this deep into probing, you should have at least 3 or 4 more of this caliber, so to say. Ask off.
so I think I need to send a photo for this one.
Yeah, no problem. Send photos. It's okay. Do you understand the point which I made there? The point was not about this question.
Yes, yeah.
The point was about how to deal with things like that, which whenever they show up, it doesn't matter what the answer is.
So how do you identify when they show up? Like,
no, do not. Do not put your ego into knowing the answer. You don't need to know the answer. What is this exam going to give you? One set of marks. What are you going to do with those marks? Who are you going to go show and who's going to really be... You score full in one exam now. Who the fuck is going to remember that? You in the future, only you. Nobody else will remember that. Yeah. And even you will forget it eventually.
Yeah.
So, see, for instance, I still remember the only time I scored full in an exam in my life, I think in 3rd standard in maths or some shit like that. I used to be like the fellow who was like, I got like 95 marks. I don't need any more. I'll sleep off. It's okay. I've gotten like, I think in my 12th standard board exam, CBSE, I had 4 subjects over 97, but not 100. So it was like, it's okay. It doesn't make a difference. I used to always make some shitty error. 1 mark, 2 marks here. Oh, fuck it. It's okay. Chalega. But the point here is, those are exams. I still remember the goddamn 3rd standard mein mujhe 100 aaya tha ek bar. So how much of an impact it should have left on the young me at that time that I had never scored a full. It was a very frustrating thing. Now looking back, I know I was just messing up slightly. But at that time, it was like, I'm an OCD fucker, man. You obviously have sensed that enough now by now. So, yeah. That was like very irritating for years in my brain. So, you have to start, not aiming for unnecessary perfection where it is not required. You have to stop that aiming for perfection needlessly. Yeah, your aim has to be for perfection eventually, but not for perfection, but for refinement now. That is your goal in these stages here. When I say refinement, The information which is going to be given to you from your teachers, etc., those are all just pieces of data at this stage. How they connect with you and how they connect with your understanding and how they eventually end up being replicated by you in the examination. Those are the three things which matter. So in this process where you're having these three stages which are happening, each stage the information will get refined more and more. You have to pay attention to the refining process now. You are now a blacksmith of information. Start treating yourself like that. Stop worrying about that one hit which is going to be going on the side of the weapon and the weapon is slightly damaged. It's in the goddamn fire anyway, so it's going to get damaged and it's going to get remade and remade and made again. So just focus on the hammering and learn how to hammer and learn how to remove impurities. That's the key thing here. So don't worry about results. And most importantly, don't think too much about exceptions. Organic lab, teachers who are from master's background, that is who have done MSc type, who are not engineering background, who are from masters, that type of background, they will like to show off the kind of organic they know with respect to information. Exceptions. Do not give a fuck about exceptions.
Yeah.
You are not playing the game of exceptions. If your logic is clean and it gets refined to the highest extent, most of the exceptions will fall in within the logic. For instance, this was specifically given by you guys in your class by your teacher. Why? Because this in your teacher's mind was an exception. Why was this an exception in your teacher's mind? Can you explain that? Can you tell me why do you think this was an exception in your teacher's mind? What was the mistaken assumption which your teacher had? I don't know whether it was mistaken assumption or not. This is my estimation of what angle he might have gone with.
Like comparing the wrong groups, maybe.
No. What is a wrong marker mostly present? Wrong assumption mostly present there. It has nothing to do with wrong group comparison. No. This is a fantastic question which your teacher has given. And he's connected such... I've never seen this question. I've never seen this case at all. The first time I'm seeing the case. I've seen other cases which are probably worse, probably different, probably... I don't know, but I've never seen this case. This is a unique case which your teacher has basically seen somewhere and basically used over here. But why...
If you expand...
Why was this weird to your teacher? Why did your teacher feel this was an exceptional case?
So because if you consider...
He considered that guy was higher priority. That's why he thought this is exception. Why did your teacher think C triple bond C is higher priority? What was the mistaken flag in his assumptions? He connected the term priority here with priority in nomenclature. Needlessly.
Maybe.
Mostly. Otherwise, you would never have thought of what to say. Effectively, it's like a tie break situation. You have come to a tie break now. Now, in this tie break, you have a choice now to decide on what is the tiebreaker option which you're going to be using. Now, in chemistry, till now, by this part, there are two tiebreakers which you have seen till now. One tiebreaker was with respect to atomic mass, which was in this Kahn and Gold pre-log rules, which was for isotopes. The other tiebreaker is your priority rules with respect to functional group nomenclature. This is also nomenclature. But in this case, you are not using those rules. So that is basically the idea here. In this case here, this is a set of purely theoretical rules. This has nothing to do with practical rules.
Reactivity now.
You understand the point? If it was something to do with practical, it would have different ways of naming. It would not be named in this fashion here anyway. So when you get to your older priority order of functional groups, what is that based on? Reactivity, practical reality of what is going to be the key group in a big molecule. So that was based on reality and practicality. This
This
is
is
not based on practical.
theoretical.
This is a set of rules based on theoretical shit here. So when it is pure
Learning, yeah.
theory, don't mix practical shit with theoretical. Because usually the rule of the thumb is the dude who did the theoretical probably did not do the practical.
Yeah.
And the dude who did the practical probably did not have the time to do the theoretical.
Yeah.
So what happens is they will both have their names associated with shit. This has nothing to do with what is correct or wrong. This is just reality. This is just reality. So each one wants their name attached to their shit. Correct? They've done work.
Yeah.
They wasted years of their life. They could have got them PhD, convinced a bunch of assholes saying, I've learned things properly, I've expanded science. Well, they obviously will try to make sure they follow their own shit. And when you get a chance to define a nomenclature, arre wow, every little kid around the world will know your goddamn name.
Yeah.
So that's the point here. So you have to stop thinking chemistry wise beyond a point, because what you think of as chemistry might not be connected to chemistry. It might be connected to ego. It might be connected to politics. It might be connected to lots of weird strings. At the end of the day. Now, at this stage here, when you're going to be having these kinds of things, you have to learn which set of rules to follow. In this case here, purely theoretical rules, go with the Khan and Gold itself. And I'm not saying your teacher thinks of this as an exception now. Your teacher thought of this as an exception in the beginning when he learned this case. Because at that time, he might have basically tried it out and thought, okay, priority group order might be more important in that sense. That is why it got placed as a flag in his brain. It is not that he is wrong in giving you this. It is that, what to say, this is a flag which was planted. I'm not interested in the right or wrong. I'm interested in seeing why was this flag planted in his brain. The flag was planted mainly because this might have been something which he thought of as priority order when he learned it or when he saw the case for the first time. Or maybe some students of his had that thought and they all lost marks in the exam. Then he remembered, oh, these kids are idiots. They do not think normally like me. I need to make sure that I force feed them or spoon feed them at this time. Let me spoon feed this.
Yeah.
So this was a flag which was planted in his brain, not necessarily through him, but through this logic of priority order is what I'm trying to say. Somebody confused at some point of time with respect to the priority there and decided they'll go with other priority order because that was also called priority. It was also called priority. So this was
Yeah.
Beautiful example though, I must say. First time I'm seeing this, but I'm quite impressed. I'll probably steal the example. No, I'm not kidding. It's a very good example. It really clearly illustrates the isotopes point perfectly. Now coming back to other doubts, you sent something to me?
1 second.
About to send.
Yes, sir. Yeah, I sent it.
Aha. Okay, so this is why you asked me cyclic alkene at that time.
Yeah. This is the part of the fused bicyclic compound.
Yeah. I heard you. Now, that is again another unnecessarily complicated crap, which I would ideally not touch up. This will only complicate shit.
Sir, my doubt is like what type of isomers are there?
So let's talk now. So let's number, shall we?
Yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Let me name the compounds as well now. I'm going to call this guy as compound 1, compound 2, compound 3, compound 4, not compound, really structure.
Hmm.
So let's start comparing each bugger.
Yeah.
So what do we compare? This pi bond is going to be having resonance. Yes or no?
Yeah.
So
Yeah.
I'm going to be having this pi bond. The double bond doesn't always exist as a double bond. Resonance, now basically it means for some amount of time it is in that structure, for some amount of time it is in a different structure. Correct? That means it becomes a single at some point of time.
Yes.
So it will have free rotation to an extent.
Yeah.
So there is no systrons applicable there.
No.
So all three of these suckers are the same.
So they're not geometrical isomers.
Yeah, they're all the same.
Oh, they're the same. Okay, yeah, they're the same.
Why?
They're the
Because
same
no
compound.
geometrical isomerism applicable.
Oh.
Right? What does geometrical isomerism require?
Restricted rotation, or yeah.
Basically, there has to be a pi cloud where you can't move around, you can't basically rotate around.
Or
You're going to
ring.
be having
Yeah.
a fixed configuration necessary there.
Yeah.
Here it becomes single, no fixed nonsense. Clear?
Okay. Yeah.
Why you seem to have still a doubt? What's your issue here?
Well,
My guess is it's probably going to be having to do with some answer which was given to you about this in school.
yeah.
What's the answer
Yeah.
given?
The first two were given geometrical isomers.
First two are given as geometrical isomers.
Yes. 1 and 2.
And they are telling you 2 and 3 are the same.
No, I mean, obviously they are, yeah, but like they're the same structure.
Okay, what to say? I'm not going to be agreeing or disagreeing on that right now. Mainly because that is something which will get a little bit more clearer to you when you end up learning a little bit more. Now, coming back to the remaining here, what was the explanation then for the remaining? All three are the same? 4, 5, 6?
No. 2 and 3, sorry, 3 and 4 is given as position isomers, and then yeah, 4, 6, 5 and 6 are identical.
So basically 4, 5, 6 are all the same, but 1, 2, 3 are different is what has been mentioned, correct?
Yeah. I mean, we're supposed to compare in the pairs given. So
now, I will not be agreeing with the point here, mainly because I know one thing over here which your sir is probably trying to teach you. Let's neglect that double bond O. Okay, I'm going to take this guy. If I take a double bond here like this, all right, and if I take, say, this, these two are cis and trans isomers.
yes.
This is cis, this will be trans. But not when there is resonance. Not when there is resonance. And there's one more point. There is one more point here to finish. I'm not done with that. This is possible only for total ring size above effective 8.
Oh,
or
yes.
This is total 10.
Yeah.
You know that already?
Yes, yeah. Yeah, he
already mentioned that to you in your class then.
Yeah, he told them. Yeah.
Not bad. Then I don't understand why he gave you this example. The logic there he's given is correct. That is correct. But no, not when there is resonance possible. When there's resonance possible, things will not be that simple. Resonance will take more priority. Resonance will change the game a little bit more. Effectively, during resonance, Yes.
What must have we thought to assume that it was geometric?
This example,
Okay. Yeah, correct. Yeah, yes. Yeah.
right?
Yes. Yes.
That is the example which he wanted to link up, but he didn't use it in that sense. The idea there is, my guess is he has told you about the 8-member ring being something which is non-planar properly.
Yes.
He would have discussed that example.
Yes.
And he would have talked about probably this boat fellow, maybe. I do not know.
No, we didn't do this.
Not yet. Okay. He'll probably do it soon.
Hmm.
Or maybe when he's doing cyclohexane, he'll probably discuss that. So the idea there is that system there, once you end up going into that 8-member rings and this planarity stuff there, the next level, which is going to be straight away graduating over there, is when you end up putting a double bond in that cyclo shit over there. If it's a 10-carbon ring, it will boil down to look like an 8-carbon ring without the saturation, without the unsaturation.
Yes, like
So,
in 2D.
Correct. So that's the advantage there. So that 2D projection is a very interesting question, which you'll normally find in very good papers, tough papers. So
Like what
that
could they
is,
ask?
yes,
What could they ask exactly? Like,
pretty much what I just showed you. They'll ask different variations of this.
like whether this compound exhibits.
No, they will ask you whether we can bend compound 1 and get it into compound 2.
Oh, so you have to like think three. Okay,
Yes.
like an IQ test.
That's the problem there. When you recognize these assists and trans, you know whatever bending you do is not going to help.
Yes.
So,
Okay, so that's a key.
So that is the kind of, it is just, if I was asking questions, I would put it like that. But rarely will you find the bending nonsense and all being asked. Something similar to it will be asked along those lines.
Yeah.
So anyway, I'm assuming then this part is clear here then, yes?
Yes, that's fine. Yeah.
Okay. My answer is 1, 2, 3 are same, 4, 5, 6 are same. 1, 2, 3 are same because resonance is applicable. If resonance was not applicable, then yes, technically 2 and ideally speaking, he should not have put the goddamn double bond there. If it was me, I would have put the double bond at a different location. Let's say I was going to be looking at this here. Instead of 1, 2, 3 being given that way, I would have used 1, 2, 3 like this. Double bond over here. Instead of putting it here or here, I would have put it here. So, I mean 1, 2, 3, 4, and 5. And each side may say 1, 2, 3, 4, and 5. So, in this here, if you put it over here, have a look now. I would have put it like this. Then I would have asked you, are they the same?
Resonance is not applicable here.
Yes. So what will happen now? Now your sir's logic will perfectly apply here. तो समझ रहा है कि मैं क्या बोल रहा हूँ? So this will be the test fellow. This will be the transcript. So in this case, the question would have been better.
In this case, the geometrical isomers.
Yes. In this case, the example works perfectly. The only mistake which was made was he did not recognize it. Resonance can play spoil sport there. You do not have to worry about resonance playing spoil sport. But if this was asked in your exam paper, some teacher will make sure they remember resonance plays spoil sport. So, all right. Next, any other doubts there? Any other questions? Any other issues which you've had so far in your current week's discussions?
1 second. So does this one exhibit geometrical isomers?
You understood the allenes and all those cases properly?
Oh, yes, sir. Yeah.
Properly?
Yeah. Yeah. Oh, you're talking about the planes and all, like.
Yes.
Odd number. Yeah.
The planes and all. Yes. I am talking about the planes. I am not talking about just the answer there. I am never talking about the answer.
Yeah, understood, sir. Yeah.
Send, bro.
I sent it. Oh, it's still loading.
Yeah.
Yeah, no.
What do you want on this?
Does this exhibit geometrical isomerism?
So, in this particular case here, this system is going to be something. Was it asked, does it show stereoisomerism, or was it asked, does
No,
it show
geometrical
geometry?
isomerism.
Very clearly asked about geometrical, right?
Yes. Yeah, specifically that.
Technically, yes.
So how?
But the problem here is it is going to be a little bit awkward, mainly because these are not going to be on the same plane. Because the ring and this will probably be on opposite planes. If they are not going to be on the same plane, then it is not going to be geometrical isomerism. It will then become optical isomerism applicability. It will be a different game at that
Sir,
stage.
I sent the full thing. Yeah.
Yeah, I saw it. So what is asked here?
Which of the following exhibit geometrical isomerism?
Geometrical. Okay. So this guy no, this guy no,
Hmm.
this guy no, this guy no, this guy no, this guy technically yes, this guy no, this guy also no. But this is where things get a little bit what to say interesting here. Only this guy seems like it. Remaining are all no's. Now, why are these guys no's? Two are same here, two are same here, two are same here, two are same here. These are all not applicable.
Hmm.
So only this one here, you're having this side and this side being different, and you're going to be having this side and this side being different.
Sir, in the
That's
seventh one, how is it? Can you seventh and eighth one? Can you explain again?
H2 and H2, no? Hydrogen, 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 hydrogen. Two are same, right?
Oh yeah, right. Yeah. Hmm. Sir,
You
but
have to have
then
different on both sides.
hmm, if you don't consider the CH2 part and you only consider the ring and the two methyls.
That's not the way it's supposed to be, right?
Hmm.
Because from the rings perspective, if you're going to be taking ring के लिए तुम्हें क्या चाहिए? You should not have a double bond there. Oh, apdi padana, you are correct. Yeah, that way I am the one who made a mistake here. I'm very sorry. These two will show cistrons.
Will show what?
These two will show cistrons. They will show ring cistrons.
Oh, cis and oh, okay. Hmm.
Ring geometrical.
Yeah, okay. Like
But
the.
this
Sir,
part,
can
there
you
is no
draw the
geometry.
two structures once?
So the answer would be, you want me to draw the two structures? Okay.
Yeah.
So we want, this is not the correct way of drawing the structure. Effectively, this is where things will be better if I'm showing you the molecular models. I assume they have started with that, but it looks like you have not yet started with that. When you're going to be having a molecule, if I'm going to be taking this ring as a planar species,
Hmm.
all right, let's say it's planar right now. If it is planar, then I can effectively have one group above and one group below. Technically,
Yes.
that is
Yeah.
carbon, 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 they're all on the plane.
Yeah.
That's the assumption. So if they are on the plane, then there will be one group above, one group below from your perspective here.
Correct. Yeah.
Right? So if I'm tilting it like this, then one group towards you, one group away from you.
Hmm.
Correct?
Yeah.
So
Yes.
how can I make them cistrons? I can have one CH3 above, and this CH3 is also above.
Yes.
Or
And H is inside.
yeah, H is going to be away.
Yeah.
You're familiar with this Sawhorse projection or not?
Like the dash and
Wedge and dash.
Ah, yes, I know.
You know what wedge and dash. What do you
Yes.
understand by the
Yes.
wedge and dash?
That means the dark dash is like coming towards us. Pretty much they're like going away from each other.
So effectively, you're going to be having a tetrahedral carbon taken when you're going to be having any tetrahedral system.
Like this shape. Yeah.
Yes, so you're going to be having this is a tetrahedral carbon here. So this is a tetrahedral system. Okay, so this tetrahedral system over here is something where you're literally going to be having this like a camera tripod. Literally, it's a camera tripod. I'll just show you my damn camera tripod here. You'll understand. Not camera tripod, the light tripod. This is the lights tripod.
Yeah.
Which is pretty much the exact same as the tetrahedral. Not exactly the same angle, but yeah, more or less. So this is going to be your tetrahedral carbon. So when you consider a tetrahedral carbon, there are many ways of representing a three-dimensional figure in 2D. All right, there are many different ways which are adopted normally. So when we are talking about different ways of drawing a 3D structure into 2D. So drawing 3D to 2D. There are many ways of drawing it. One such way is going to be your wedge-dash. So solid wedge and dashed wedge or hashed wedge, whatever. So effectively, the 4 bonds on this single carbon here. Let me put different colors on each of them so that it is more clearer to an extent. So if I'm going to be having this as the compound here. All right. As you can see, this is something where there is nothing on top here, nothing here. So it's a hydrogen, and 3 random fellows are there on the tetrahedral carbon. So this molecule, how can I show it to you, or how can you draw this molecule? If I'm asking you to draw this, you can see it now in 3 dimensions. How do you draw this? How would you draw this? How you draw it would be, you take 2 on a plane. Let's say I'm taking the nothing and the blue on one plane. This is going to be the plane where I'm going to be having, as you can see here, the nothing and the blue are on my palm, on the plane of my hand. So I'm going to be having them on the plane of my hand like this. What's going to be happening if it's like this from your point of view? You can see that the red is coming towards you, but the red is blocking the white. Correct?
Yes.
The red is blocking the white there. So the red is blocking the white there, and simultaneously, from this angle, if you look at it like this, from this angle over here, what is it looking like? It looks like the white is blocking the red in this case.
Yes.
Correct. So there's one bond coming towards you and one technically going away from you. So look at it like this plane now. So this is the plane right now. So from this plane's point of view, if my viewer was here, right? So if the viewer was on this side here, the red will be coming towards them. While the white is going to be going away from them. If the viewer is on this side, the white is towards them, the red is away from them.
Yes.
Correct? So, depending on the angle of the viewer, you're going to have to draw. So, when you're drawing a 3D shape, you will draw it as, let's say this hydrogen is going to be here, blue over here, and I'm going to be having, let's draw this guy now. What's happening? The blue and the hydrogen are on the same plane now. Red is on this side, white is on this side. So from your point of view, the red is coming towards you, the white is going away. So effectively, the one which is going towards you, you will be putting it as a solid wedge. And the one which is going away from you, you put it as a hashed wedge. That's basically the idea here. This is basically called as sawhorse projection or wedge-dash projection. You'll be learning more about this before you go into optical activity. So pretty much the next thing you'll be learning after the optical activity part there will basically be this only. Because without this, you cannot go into the next thing. You'll be learning 2 or 3 ways in which a 3-dimensional molecule can be converted into a 2D image, which can be drawn on paper. You need to learn how to draw these structures because you'll be given only those structures. And you have to get comfortable with them.
Okay.
That's going to be the case. So, all right. And how comfortable are you with? They've just started this wedge dash for you, I suppose. Yes.
No, we've been doing it for a while.
You've learned Newman projection.
No.
So you'll be doing it only now. You have not learned it then. They're just showing you that so far because that is easier, and you've learned that
Yeah.
in chemical bonding. Maybe thoda sa they have
Yes.
shown you, but no, you are going to learn them again now in a proper.
Okay.
So when you have learned them, after that we'll sit and discuss them. Now,
Okay.
any doubts you had collected over the week?
So we wrote.
You understood the 7th and 8th over here, I suppose. Yes.
Yes, sir. Yeah.
And the 6th.
The sixth one. Oh, yeah, the sixth one. Can you?
The 6th was in this direction. Here
Yeah.
and here are different. Here and here are different.
Okay, that yes. It's like a
Straightforward,
AB
huh?
and then CD.
Hmm.
Yeah. So, but
Hmm.
so you just consider the upper part to be some, but then they're attached. No, would that make a difference?
How does it make a difference? You're having here there is one, here there is one. These two sides, if they are the same, there is a reason to not bother. But this side there is a CH3 here. So this side and this side are different. This side and this side are different.
Okay.
Correct?
Okay, that's what I was thinking.
And there is going to be inhibited rotation over here.
Yes, because of the double one. Yeah. Yes.
Next.
Uh, So, how like there are a few formulas for the number of geometrical isomers, right?
No.
I
No.
mean, for like simple ones.
Oh no.
Oh, I had one more doubt. It's I forgot what this is. Oh, so the question was
Avoid memorizing too many formulas. If you're memorizing a formula, you're going to get a few formulas from here. I'm guessing you were given a question of this sort.
hello.
Let me
Hello.
make the question up so that you realize that, yeah, that is possible.
Yes, sir. Yeah, your video got stuck.
You got something like this as a question?
Yes, sir. We've done this. Yeah.
Yeah, I figured. And you are told directly apply formula, get the answer.
Yeah. Find the number of sites which.
Yeah, I'm not going to change that. Apply formula, get your answer.
Okay, sir. I have
I'm not
one.
going to change it.
Okay, sir. There's
Huh.
cyclobutane, and then there are 3 carbons. Sir, not 3 chlorines. My bad.
Number, name.
Okay. Sir, 3 chlorines anywhere. Like just
Number, name.
okay. 1, 2, 3
Trichloro on which
trichloro.
carbons?
1, 2, 3 trichloro.
2, 3 trichloro. Cool.
And then CH double bond CH3. Oh, sorry.
Name the group. Name the group.
Prop 1 in oil. Sorry, oil. Oil.
Prop 1 mean I'll okay now. Okay. This guy?
That's it. Yeah. Yes.
Okay.
Sir, the answer, like with my logic, was tallying, but then I'm not sure if it's correct. So what I thought
What
was,
was asked?
the number of geometrical isomers.
Okay.
So what I did was, so the ring and the double bond can exhibit geometrical isomerism. So the like in the formula, n value will be 2, right? Like
Sorry.
so there are two possible sites in which can exhibit geometrical isomerism, right?
First, let me interject for a second here. Your question here was number of geometrical isomers for this compound, correct?
Yes. Yeah.
Now, do not apply a formula.
Yeah, I'm not. Yeah.
Do not.
Yes.
Logically break the problem down, solve it.
Yes, sir. Yeah.
Formulas
So
are going to be useful when you are going to be having, what to say,
simple
no, when it is
compounds.
going to be exactly the same type of case where you are told the formula works for that goddamn sure.
Okay. Here it's a doubt.
The
Yeah.
problem with the formula is formulas are highly fallible,
Limited. Yeah.
very, very limited. So never, ever, ever, ever think a formula which is given will work everywhere. If a teacher has taught you a formula, they should absolutely tell you where the fuck it doesn't work. At
Yeah, he
least.
gave us yeah.
Yeah, he would have told you where it doesn't work. These cases, avoid using it, or he would have told you only in these cases use it. Your job is to actually take it like Vedavaka. Only in those cases, use it. Don't think too hard.
No.
Your teacher has basically struggled through, has seen that these cases are being asked stupidly regularly because some bugger in some place is getting irritated and is asking stupid, shitty questions. And these guys are also basically using it in exams.
Yes.
And the actual way to do it is complicated, time consuming. This is easier to get it done. Get it done.
Yeah.
Now, you will get another set of formulas when you're going to be doing optical activity soon. I'm quite sure he'll be giving you. If he's giving you for this, he'll give you for that also. My recommendation, don't come and ask me for those formulas and how they work. I avoid formulas like a plague. I do not like formulas because they put a bad filter on your brain. They limit your thinking.
Makes sense. Yeah.
And
Yeah.
I like freedom in my thinking. I do not like
Yeah.
to control. Now, let me go with your question here. These guys will show geometrical isomerism.
Yes,
They
that's what.
can all do
So
up-down type of shit. So,
yeah.
when you're going to be having these 4 groups, all 4 of these groups can do up-down type of shit. So,
Yeah.
don't think about this geometrical isomerism. That is not going to be the thing. That is never going to be the thing. This ring wala geometrical isomerism is going to be the key thing there. So, start off with the numbering part here. So, let's say this is going to be 1, 3, 4. Okay. The way to go about it is go with up, 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 up.
Yes, that's right. Yeah. Up,
Flat,
up, down.
up, 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 up. That is the way to proceed and understand. Eliminate out groups. This is funny, fellow. These are all chlorines.
Yeah.
Now you can check in these numbering also, because if this is 1, 2, 3, 4, the same thing can be in reverse also.
Yes, exactly. If it's these two, it's the same as
The way to identify number of geometrical isomers in these kind of cases, actually sit down and do sets and get it done in a mutually exclusive manner, which is pretty much the same goddamn rules you've been following till now. Correct?
Yeah.
Do
Yes,
the
sir.
same principles. Go back to first principles. This, what to say, formula approach and all will work for people who are not capable of doing the first principles work. What you should do here is, when you are tackling these kind of questions, you should effectively try both. Your teacher has done the hard work and found out that formula works in some cases, correct? So you will try out the actual approach like the way I just showed you now. You will also try out the formula approach and see if they match up. Why? Because you will add data to yourself. If
when
the
they
formula
match up, when they
is in
don't.
some cases, it can expedite your time if that same stupid case shows up in an exam.
Yes. Yeah.
But you will not
Yes, sir.
bank on formula. So you will actually physically try out different cases by the proper method, see if it matches with formula, then decide, okay, this is matched with formula. I have confirmed for myself, so I can blindly use formula. You test it out for yourself.
Okay.
There is no other approach there. Fair enough.
Okay, yeah.
So
Yes, sir. Yeah.
I basically
Sir,
did try all that nonsense when I used to teach. I realized it is just not worth memorizing formula. There are
okay.
so many tiny cases which will screw
Mm.
you over, where there will be sudden symmetry appearing. Suddenly, one or two cases numbering will be in reverse direction. You should not add, you should not count them. Formula generally takes into account quite a few of those things. I do not deny that. It will give a much more cleaner answer. But I never trusted formulas well enough. That was my mistake also probably. If you are convinced by formula, which your teacher has taught you, my recommendation is sit and try the approach which I just showed you here, the up-down type of shit. You will get the same answer. This will be far more satisfying. But it is going to be longer. There is no question of that. It is going to be longer. It is going to be consuming more time. So if you find the formula working for quite a few of these cases, some of them at least, and you work them out, please share them with me as well. I'm also curious to know where all this works. If you can reduce my labor properly, why not?
Yeah.
Why not? Huh? Certainly. So, that's
Sir,
basically what I would say about formulas there. Yes.
sir, in this example, I didn't really use formula, but then I want to know if this method is valid. Like, so from there two, like you consider the double bond and the entire ring, the two sides of they both exhibit geometrical isomerism. So from those only the possible cases will be four, right? Like one, yes, like one exhibit, one doesn't exhibit, like that. Four cases will come, right?
Go on.
So and then again three chlorines are there. So they have three chances to be front, back, front, back, front, back. So can we do 4 into 3 into is equal to 12? I'm getting the same answer. Like so. Does that make sense? Or is there a possibility that if the carbons are front and back, you have to see with
Effectively, what
respect to
you're
the
trying to
chain?
say here,
Hello? Hello?
this itself, along with
Yes, sir. Now I can hear.
guy and this guy. So this part, along with this and this, you counted, you got 4.
Yeah.
Then you realize you'd count this also and this also.
Yeah, the chlorines as well. Yeah.
But then why did you multiply by 3 then?
Because there are three cases, like this one carbon could be front, the middle one could be front, or two of them could be front.
See, the thing here is why you multiplied by 3 is not based on that then.
Why?
I am not going to explain that part right now. That is something you will understand a little bit more once you have done a little bit of optical isomerism. Your answer is not wrong, but not for the reasons you think. In a sense,
Okay.
what did you do? You did 4 yahan se multiplied by 3.
Yeah.
Why? Because you have accepted that यहाँ पे A, B, C, D structures आ रहा है तो यहाँ पे 3 जो structure आएगा हर structure के लिए there is going to be an A, B, C, D applicable.
Exactly. Yeah.
Correct.
Yeah.
Now, how did you arrive at the 3?
The
The
chlorine
3 is correct. But the 3
then
is actually because these two fellows, 2 and 4, chlorine here, can be up, which is the same as down in some cases, or it's like this, up,
down.
you become down, or it could be that the up down is going to be the same as the down up.
Yeah.
What will happen is, in one case, you'll end up having, that is among the A and B. For A and B, you'll probably be having this 2 plus one of these happening. Let's call this as, what to say, case.
So again, cases apply here. Okay.
No, you're not understanding the game here properly. What actually happens, I'll tell you. For A and B, I will have, let's call these as number 1, number 2, number 3, and number 4. Roman numeral fellows. Okay. For A and B, it will be 3 cases, which will be 1, 2, and 1 of 3 or 4. Because 3 and 4 will both be the same, or something of that sort.
But why?
1 and 2 will be both the
Then
same,
in that case, 1
and 3 and 4 will be different. No, you're not understanding the point over here still. You took that 3 like this. I'm telling you the 3 is not like that.
Okay,
You
but
did
then
4
why?
into 3 blindly, correct?
Yes, yes, yes.
You did 4 into 3 blindly, right? My
Hmm.
internet connection is unstable. Oh, fuck. Okay. So you did 4 into 3 blindly without recognizing why you are doing multiplying by 3. What I'm trying to
Yeah.
tell you here is that 3 is not easy to get.
Oh.
You're
Okay.
overestimating your 3 there. Right now, it is a goddamn lucky guess.
Okay.
That's all it is.
Okay.
So that's what I'm trying
So,
to explain. You're having 4 structures A, B, C, D here, correct?
yes.
A, B ke liye you will get 3 multiplied by 3, and B, C, D ke liye you will be getting multiplied by 3. But the 3 for A, B will be different from the 3 for C, D.
So, how do you know that it can be 1 and 1?
No, because I know you'll have to sit and try when you have learned some optical activity and some optical isomerism.
Okay.
Once you have learned that a little bit more in detail, you'll understand what I'm trying to explain here. For now, the idea is this. In A and B, mostly up will become same as down. For carbons 2 and 4, the chlorine is there. And in the other case, up down will become the same as down up. When the up down becomes the same as down up and down will be different. When the up and down are being the same, then the up down and the down up will be different.
Yes. Yeah. Okay.
Let me put it like this. Currently, what's the 4 structures you got? Think.
The inner one, like, 2 possibilities are there, no? Like, this.
Right? In this group, I can have a cis or a trans.
Yeah.
Correct?
Yes.
This was 1 into 2.
Again, the double bond can show.
No. Double bond is cis or trans is done.
Oh, the ring, no?
Then this will go here.
Okay, understood. Yeah. So again, 2 more cases.
This was the first one. Okay, so this is your other 1 into 2. So this is your
4.
A, B, let us say. This is your C, D, let us say. Or this could be A, C, B, D, whatever. Now, where are your others coming? The others are coming over here and here.
Yes.
Right, the chlorine. Okay, this is a 4-membered ring, not a 6-membered.
Yeah. Even serious.
But yeah, you get the point.
Yeah. I got it. Yes. Yes, sir.
Huh? Yes, sorry. So group chlorine. So this can be cis or trans. And hydrogen group cis or trans, chlorine above, and hydrogen group. Now you're going to be having chlorine present on the other 2 fellows there, correct? So when you're going to be having chlorine present on the other 2 fellows over there, let's talk about one thing here now. If I have, say, chlorine here,
understood.
up and chlorine here up. And if I put the same chlorine here up and the chlorine here up, Are these two going to be the same structure or different structure?
Different.
No, they are same.
How?
If this was cis
Oh no,
over
no,
here
no, same.
and this was cis over
Same.
here, they'll become the
Correct,
same.
same.
Because
Same,
this
they'll
side
be.
and this side will now be the same. That means these two
Yes.
are technically not going to be cis transfer.
Okay, so that's why you're removing one of the. Okay.
You understand the point now? In this case, the
Yes, sir.
up and up are different than down and down. All right. So here the up and up are different. So the up and up are same here, but these two are going to be what? So here this was up over here. This was down over here. So this up and this down makes them the same.
Yeah.
Effectively, if I had up, and an up over here and a down, up here, these are both same.
Yeah.
समझ रहा है कि मैं क्या बोल रहा हूँ?
Yes, sir. Yeah.
So that is going to be the type of thing which you need to start weeding out.
So, or I think easier method would be like you can just take, instead of that entire group, you can take some like other simple one thing and then multiply by 2 again.
I am not saying you can't do it like that. That is what I'm doing also over here. Basically, you arrive
It's
at
much
how
easier
many
like that.
possibilities are there in this and then multiplied by 2.
Yes,
because the
that's what I'm
group will
saying.
have
6
cis
into
trans.
2.
So it is actually 6 into 2, not 4 into 3.
Yeah, 6 into 2. Yeah, 6 because the CL, and some other group.
You understand
and
the
then
idea
into
there?
2 the.
So better approach
Yes, sir,
for
got it.
2 is actually not 4 into 3, but 6 into 2. You go 4 into 3, you are going the dangerous approach there.
Yeah, lengthy approach. Yeah.
You understand why I was not happy with your 4 into 3 there? If you had gone with
Yes,
6
sir, yeah.
into 2, that is a far better approach, which is more foolproof. 4 into 3, the complication which comes out over there is which 3? For which 4? For which ones?
Yeah, correct. Yeah.
And understanding which ones is going to be a complicated game
there.
So that is basically the key there. All right. So I hope you understood what I'm talking about there in that particular case. It's been too long already. I'll have to shut up. Any other last minute questions?
No, sir. No.
You still seem to have something on your goddamn brain, but
No, sir.
okay. All right. Next session will be more or less a continuation, I suppose, of this. As I said, go with questions. Any question, doubts which you're having, from what I'm seeing, you are quite competent in organic. It's not a problem at all for you. Your understanding seems very clear. So go with your doubts, settle your issues first, as in when you have them. If there are any things which I find you will need to know to understand better, I will obviously poke.
Okay.
Okay then, good night.
Yeah.
Have a
Okay,
good day.
sir. Thank you, sir. Yeah. Good night, sir.
Bye.